Okay, so I have spoken about various centers. Now let me tell you a little bit about orthocenter. Orthocenter. Now this orthocenter is nothing but point of concurrency of altitudes, right? So if I've got this triangle here, okay, if I draw a perpendicular from this vertex to the opposite side, similarly if I draw a perpendicular from this vertex to the opposite side and they are meeting here, right, then the third altitude, if I draw from this vertex to the opposite side, will also pass through this point, and this point of concurrency is known as the orthocenter. Let me denote it by H. Okay, so this is orthocenter. So it is point of concurrency of altitudes. Okay, now we know already. Let me draw a triangle once again. I'll talk about the coordinates of orthocenter also in a short while, but let us understand a few things. See, let us say this is the perpendicular bisector of this base. Okay, and let this be the altitude, one of the altitudes, right? We have got three altitudes, and this is perpendicular bisector of this line, this side of the triangle. Okay, so this is 90 degrees, this is 90 degrees, so these two lines are parallel, this altitude and this perpendicular bisector of the base, these are parallel to each other. Okay, and this is perpendicular bisector. So what is this point? This is midpoint of the base, midpoint. If I join this midpoint with this vertex here, what will be this line? This line here is the median. By now we know that point of concurrency of medians is known as centroid. Point of concurrency of altitudes is known as orthocenter, and point of concurrency of the perpendicular bisectors is known as circumcenter. Let us denote it by O. Okay, so if I ask you on which line will the centroid lie, you will say it will lie somewhere on this median. Okay, and we know exactly where it will lie, right? It divides the median into 2:1, where this segment towards the vertex is twice this segment here, which is towards the base. So let this be the centroid. Okay, and on this perpendicular bisector, will lie the circumcenter. So let us say the circumcenter lies here, somewhere on this perpendicular bisector. Similarly, you can say that H or the orthocenter will lie on this altitude. What I'm trying to say here is that it is the point of concurrency of altitudes. So it will certainly lie on all the three altitudes. Okay, for now I have taken just one altitude. I want to display something to you. If I join these 3 points with a line, right, these 3 points lie on a line. What I mean to say is these 3 points are collinear. These 3 points are collinear, and this line has got a special name, Euler's line. Euler's line, right? Now if you look at these two triangles, this triangle, let me change the color. If you look at this triangle and this triangle, what can you say about these two triangles? This angle here will be equal to this angle. These are vertically opposite angles, right? Now we know this line is parallel to this line because both of these lines are perpendicular to the same base, right? So these two lines are parallel. So if these two lines are parallel and this line here, my Euler line, is acting as the transversal, right? So what can I say about these two angles? Give me a moment. This angle and this angle. These angles will also be equal. Similarly, you can say about this third angle, this angle will be equal to this angle. So these two triangles are equiangular or similar triangles. So the ratio of corresponding sides will be equal. So let me write the ratios of the corresponding sides. Okay. Now this point, what is this point? This is orthocenter. This is circumcenter. Right. So I also know that this centroid divides the median into 2:1. Right. So I already know this ratio. Let me give these vertices the names A, B, and C. So if I let this midpoint be M and base of this perpendicular be P. Okay. So if I ask you what is AG is to GM, you can say it is 2:1 because we know it already. Now AG by GM is also equal to HG by GO. It is also equal to HG by GO because of the similarity of these two triangles, right? So the corresponding sides are in equal ratio, or the ratio of corresponding sides is equal, and it is equal to 2:1. So you can say that if I draw this line, meeting these three centers, right? If this is, let us say, the orthocenter, and this is the centroid, and this is the circumcenter. This is orthocenter, this is circumcenter, and this this is the centroid, and this is circumcenter. So now I know that this line is divided by this centroid in 2:1, right? So the centroid G divides line joining H and O in 2:1, or you can say HG is to GO is equal to 2:1. It is important that you memorize this fact, right? And now let me tell you about the coordinates of all these centers once again. So, and I haven't told you about the coordinates of the orthocenter as yet, right? So let me write the coordinates of centroid first. Obviously we are talking about a triangle with the vertices x1 y1, x2 y2, and x3 y3. So what will be the centroid? It will be x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Right? What was the in-center? In-center has got coordinates ax1 plus bx2 plus cx3 divided by a plus b plus c, and ay1 plus by2 plus cy3 divided by a plus b plus c. Okay, in the short form, if you know the sigma notation, then you can write these as sigma x1 by 3, sigma y1 by 3. These coordinates can also be written like this, right? Similarly, you can write these coordinates in sigma notations as sigma ax1 divided by sigma a, comma. Similarly, you can write the y coordinate. Okay, so now you know the coordinates of centroid as well as in center. About x centers coordinates, I've already told you that there will be 3 x centers, and to write the coordinates of each x center, let us say if I write the coordinates of x center opposite to the vertex A, right? I'm talking about the x center of the circle, exterior circle that we draw opposite this vertex A, then I'll just change the sign here and here. So I'll write the coordinates of this x center only. Rest you can write yourself. Minus ax1 plus bx2 plus cx3 divided by minus a plus b plus c. Okay. Similarly, you can write the y coordinate as minus ay1 plus by2 plus c by 3 divided by minus a plus b plus c. Okay, you can write the coordinates of this x-center and this x-center yourself. Now let me talk about the coordinates of circumcenter. So we memorized the coordinates of circumcenter using the coordinates of incenter. We just replaced a with sine 2a, and similarly b with sine 2b and c with sine 2c. So what were the coordinates of circumcenter? These are x1 sine 2a plus x2 sine 2b plus x3 sine 2c divided by sine 2a plus sine 2b plus sine 2c, comma, similarly you can write the y coordinate. Okay, now to write the coordinates of orthocenter, we will again use the coordinates of incenter to memorize the coordinates of orthocenter. Now in case of orthocenter, you will just need to replace a with tan a, similarly b with tan b and c with tan c, and you can write the coordinates of orthocenter like this: x1 tan a plus x2 tan b plus x3 tan c divided by tan a plus tan b plus tan c. Okay, all right. Similarly, you can write the y coordinate. Okay, what are a, b and c? What are these angles? These are these angles, interior angles of the triangle ABC. So this is angle A, right? And this is angle B, this is angle C. I hope I have written all the coordinates: centroid, incenter, excenters, circumcenter, orthocenter, right? So I hope you will be able to memorize these coordinates and you have got the basic idea of these centers. Okay.